Welcome to the next video about application of derivatives. Now here we're just gonna basically be looking at optimization. Now we have a rectangle that has a width of x. Now they want the maximum area of the rectangle if its perimeter is 20 meters. Now, what do we know about a rectangle is that the opposite sides should be equal. So we already know this side to be this side, since the width is provided to be x. That means we already know the other side to be x. Now the perimeter of this is going to be 20 meters. So I'm just going to let the unknown side be a. It can be any variable. I'm just going to let it be a. So this means that when you sum up all those sides, so that means you'll have 2a. That's because it's this side and this side, which will form 2a. Then you'll have this side and this side, which will form 2x. And that will be equals to 20. Now you're going to divide everything by 2. Then you'll have a plus x equals 10. Then from then that makes a to be equals to 10 minus x. So you have solved for the missing side of that. That's 10 minus x. Now the area of a rectangle is given by length times width. Then that means that we're going to have 10 minus x as the length and the width of x. So that's the area of a rectangle. Now since we're looking for the maximum area of that, we'll have to find the derivative of that area. So here's just a matter of a product tool. Here's just a product tool. So you're going to derive 10 minus x. You'll get the derivative to be minus 1. And then you multiply by the other function, which will just be x. Then you're going to add 10 minus x multiplied by the derivative of x, which will just be 1. Then you can simplify the derivative. Then here you'll have minus x. And then here you'll have 10 times 1, which is 10. And then here you'll have minus x times 1, which is minus x. Then here you'll just simplify the derivative to be minus 2x plus 10. Now, from here, for maximum or minimum, you have to first set the derivative to be equals to 0. So setting the derivative to be equals to 0, in this case, we're looking for maximum. For maximum, we're setting the first derivative to be 0. Then that means that minus 2x plus 10 is equals to 0. That means that minus 2x is equals to minus 10. Then you can divide both sides by minus 2. Then you'll get that x equals 5. And if x equals 5, what's the area? Remember, the area is provided to be 10 minus x multiplied by x. So you'll have 10 minus 5 multiplied by 5. That's the area. So that makes it to be 5 times 5. So that's going to make it 25 meters squared. So that's the maximum area of this rectangle, provided it has a width of 20 meters. So that's how you can work that out. So it's basically not that difficult. You just analyze what's provided, and then you use that information to get what's been asked. Now next, let's do this question. Find the minimum vertical distance between the two graphs. Find the minimum vertical distance between the two graphs. Now we're looking for the minimum distance between these two graphs. Now, when looking for the distance, you have to take into consideration that we are only looking for the vertical distance. I'm going to try to graph these functions. We have the x-axis there, and then we'll have the graph y equals x squared plus 4. Okay. It's gonna be something like this. It has shifted about the x-axis by 4. Then that's the graph y equals x squared plus 4. Now we have another graph x to the 4th minus 8. That graph is going to look something like this. No, remember, this is not to scale. I'm just showing you the graphs. Then you can see the distance increases between the graphs like that, and the distance increases. And at some point, we'll have the minimum vertical distance. We're only considering from up and down this vertical distance. Now, you can see that the graph x squared plus 4 will be higher than the graph of x to the fourth minus 8 graphically, even though it's not to scale, but we can see what's happening here. So that makes the vertical distance to be y1 minus y2. So you basically take the upper graph it's x squared plus 4. Then you subtract the lower graph. The lower graph it's x to the fourth minus 8. So now that means d will be equals to x squared plus 4 minus x to the fourth plus 8. That means that d will be equals to x squared minus x to the fourth plus 12. So that's the distance. Now you have to find the derivative of that. Deriving that will get 2x minus 4x to the third. So remember, when we're looking for minimum or maximum, we have to set the derivative to be equals to 0. Setting that to be equals to 0, we get 2x minus 4x to the third to be equals to 0. Then we can factorize by 2x, and we'll have 2x into 1 minus 2x to the power 2. Then this will be equals to 0. Then from here, we have 2x into 1 minus root 2x into 1. Let me keep plus here, and then I say 1 minus root 2x. So that's how you can like factorize that one there, and then that means that x equals minus 1 over root 2, or x equals 1 over root 2, or x equals 0. That's how you can like evaluate those ones there. Then you have to substitute that to the distance and see which one you get minimum. If x equals 0, that makes the distance to be 12. And if x equals 1 over root 2, 1 over root 2 and minus 1 over root 2 will equate to the same thing, because the square will get rid of this negative, then it will basically be the same thing. Then 1 over root 2 square, that's half. So you'll have half minus 1 over root 2 to the power 4, it's the same as half square. So you'll have 1 over 4, and then you have plus 12. Plus 12. Now, 12 is the same as 48 divided by 4, and half is the same as 2 over 4. Then you can just evaluate this one like this. So you can just say 2 minus 1, which is 1, and plus 48. That makes it to be 49 divided by 4. So that makes the distance when 49 over 4, when either x is 1 over root 2 or negative that. So what's 49 over 4? How can we convert this to decimal place and compare it with 12? Notice that 49 is the same as 48 plus 1. 48 divided by 4, that's 12. Now 12 plus 1 over 4 is larger than 12. So this is not the minimum area, but the minimum area is 12. The minimum distance, not the area. The minimum distance is 12. So it's this one. The other points will result in the larger distance between the two functions. So you'll have the minimum vertical distance to be equals to 12. So that's how you can like find the minimum vertical distance of the two graphs between the two wells. So it's just application of derivatives. You just analyze the question and do what's asked. Find the derivative and equate it to 0. That's how you can like basically work it out. It's basically simple, really. There's nothing complicated about this. Now let's look at this question. Find the point on y equals 2x plus 5 closest to minus 1 is to 0. Now we're looking for a point on this function closest to minus 1 is to 0. How can we do that? How can we find that? So let that point on this graph, be, suppose we have a is to what? If you substitute a here, you'll have 2a plus 5. I'm just letting that point closest to this point to be a. If you substitute a here, you'll have 2a plus 5. Now we want this point to be close to minus 1 is to 0. Now it's just a matter of distance. We know the distance formula. D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So that's how you can, this is the formula that we know. So you just plug everything in. You have two coordinates, 1 and 2. Then you just plug them in. Then it's basically that simple. So you have d equals the square root of x1, in this case it's a. Then you have minus x2, so you'll have negative into negative, then you'll get positive 1. Now y1 is just 2a plus 5. So you'll have 2a plus 5 minus y2 is 0. So you'll have something like this. Then you'll get the distance between the 2 points to be, you just expand this. So you'll have a squared plus 2a plus 1. That's when you expand this one. And now, then you expand this. 2a squared, that's going to be 4a squared. Now 2a times 5, that's going to be 10a. Then 10a times 2, that's going to be 20a. Then you'll have 5 squared, that's 25. So you'll have something like this. Then now you just simplify. Now a squared and 4a squared, that's going to be 5a squared. Now 2a plus 28, that's going to be 22a. Then you'll have 25 plus 1, which is 26. And now you're going to square both sides to like make things simple. Then you'll have the square of the distance to be equals to 5a squared plus 22a plus 26. Now, I said when you're looking for, remember we're just looking for a closest, that means we're looking for the minimum distance of that. So that means we have to set the derivative to be equals to 0. So we derive that, so we'll have 10a plus 22. When we derive that, then you set the derivative to be 0. That means that 10a plus 22 equals to 0. Then that means that a is equals to minus 22 over 10. If you simplify, it's going to be minus 11 over 5. Then you're not done. We're looking for the points. So we only have the x coordinate here. That means we can find the y coordinate. The y coordinate is 2a, and in this case it's minus 11 over 5. It's 2a plus 5. So we'll have 2 times negative 11 over 5. So that's going to be minus 22 over 5. Now, do you agree that this 5 is the same as 25 over 5? This 5 is the same as 25 over 5. 25 over 5 is 5, so I didn't change anything. So now minus 22 plus 25 is going to be equals to 3. Then you divide that by 5. Then that makes the point closest, the point on this graph closest to this point is going to be equals to, is going to be coordinated minus 11 over 5 is to 3 over 5. So that's the point. That's the point on this graph closest to minus 1 over minus 1 is to 0. So it's basically this simple, really. You can just like work it out. This simple, really. It's just application of derivatives. So optimization, you just have to analyze what's provided, then use what's provided to get what's required of you to do. So good luck, and basically this is how you can like find the minimum and maximums of something. So thanks for watching. Don't forget to share and subscribe.